Okay, good morning everyone. So let us start. Okay. Yes, any problem? Sorry. So yesterday we discussed regarding I'm so sorry. So yesterday I discussed give you a brief introduction about beams, right? Are you clear about beams? What is a beam and everything? So what today we'll discuss is we'll discuss those things only but in a more elaborate manner. So basically what is a beam? Yeah, that day yesterday I discussed a beam is a lateral member whose cross-sectional dimensions are very small compared to its length. Now, a beam in structure may be defined as a member that is subjected to certain external loads, which means what? It is experiencing or it is under the influence of certain external loads. So now there are different types of loads. So these loads may be dead load, live load, self weight, whatever may be. Okay. So now in a beam, what happens is that the load acts only in what? Perpendicular to the beam. Okay, that means what? Suppose this is a beam. So the load will act in most cases it will be perpendicular. Okay, so now according to the support, look, according to the support, there are different types of beams. First of all, number one is what? Number one is simply supported beam. So in some simply supported beam, what happens is that the beam creates only translational constants and only translation movement is allowed in one direction with the help of rollers. This beam is like this. The load is, we always remember, in a simply supported beam. Suppose we draw a simply supported beam in this manner. Okay. Now in this simply supported beam, this one and this one, these two are the what? Supports. Okay. These two are the what? Supports. And the load is placed like this. So the beam is simply supported here. Just remember that. Now, if we come to number two, number two is what? Cantilever beam. So in cantilever beam, what happens is that the beam will look somewhat like this. So in cantilever beam, the beam will look somewhat like this. So this end, one end is what? As per definition, it is fixed. So the one end is fixed and the other end has one load. Okay. Now this kind of beams are called cantilever beam. So that means what? One end is fixed. This is the fixed end. The fixed end is denoted in this manner. Okay. So this is the fixed end. So this is the fixed end and this is the free end. Okay. So this is known as a cantilever beam. Now for cantilever beam you can see like sometimes in the roof there is certain overhanging portions. So those portions are termed supported by cantilever beams. Okay. Now the next one is what? Fixed beam. So this is the definition of a cantilever beam. That means what? It is fixed at one end and free at other end. Now look, what will happen? The at the fixed end, suppose this is the fixed end, right? Suppose this is the fixed end. Huh. So at the fixed end, what happens is that it is fixed. That means it is stiff. That means it is not able to translate or rotate. That means what? It is not able, since it is fixed, so it is not able to either translate or what? Rotate. Translate means movement and rotate means simple rotation. But then the free end, okay. But then if you see at the free end, it may do both. That means at the free end what happens? It is not supported by anything, right? So that means what? There can be both rotation and translational movement. Now how this movement will occur? I'm telling you. Wait. Suppose this is the cantilever beam. Okay. Now you are given certain loads. Okay. So if you are given certain loads, what will happen? There may be what? Rotation, or there may be like this. This will come like this. So this will come like this. Okay. So what will happen? So this is translation movement and this is what? Rotation movement. Right. So in this manner, I can in the free end it can do both. Therefore what happens? Therefore the reactions of this force will exist in this part. This is the basic fundamental thing of cantilever. Now in fixed beam is just like this. Now it is fixed at both ends, so the fixed are denoted in this manner. Okay, so this is a fixed beam. That means what? It is fixed at both the ends. Okay, got it? So these beams are fixed at both ends. So this is known as actually what? Fixed beam. Now after that, it is what? Continuous beam. Now in a continuous beam, what happens is that the beam is supported by, now here is one support, here is another support. If this is having two supports, then it is a simply supported. Okay. Now if it has more than one, two, like it is continuous, then suppose another support is here, then it is known as what? Continuous beams. Okay, it should be clear to all of you. I'm showing you certain examples now. I guess it should be clear for all of you now.
Yes, sir.
Wait, if I let me show you certain examples, it will be more clear for all of you. Apart from this, we have two other form of beams. So these two are known as overhanging beam. Okay, and basically there is another one which is very important, overhanging. Okay, so now what is actually a continuous beams? Okay, can you see the screen? Can you see the screen, students?
No, sir.
Okay, give me a minute. Now is it visible? Is it visible now?
Yes, sir.
Yep. So look, these are the
Different
different.
type of beam, sir.
Yeah. So number one is what? Simply supported. Okay. So in simply supported, what happens is that, look, if you see the supports like this, A and B, so it is simply supported. The distance between the two supports is what? L. Got it? So in figures, you can see it in this manner. Okay. Now after that, it is what? Fixed beam. Look, I draw it like that. Fixed beam like this. Now this is point A, the first one, and second one is what? Point B. And the distance between them is L. Okay. So that means what? The distance between the two fixed ends is L. Now what happens is that next one is, this is the example of fixed ended beam. After that you come cantilever. Remember this thing. This one in cantilever, what happens? One end is fixed, and the other end is free. Okay, so this is cantilever. Now in continuous beams, what happens? The beam is continuous. Look, if this is hidden, here is another support here. Huh. So these are the three supports: A, B, and C. Right. So if these are three supports, then this is known as a continuous beam, or this is a continuous beam. Right. Then you come what? Overhanging beam. So overhanging beam A. B. Now there is one overhang between B and C. That means what? In overhanging beam, it is a combination of simply supported, this one, and cantilever. Look, in B and C, it is cantilever part. That means what? It is overhanging, coming out a bit. But between A and B, it is having simply supported, or like this. This is an example of overhanging beam. Is it clear now? Is it clear, everyone?
Yes, sir.
Okay. So now after that, what we will do is we'll go to the types of loads. Okay. So we'll go to the types of loads. So you got to know what are the different types of beams. Huh? Now what happens is that there are basically three types of loads. Okay. So number one is what? Concentrated loads. Okay. So number one is what? Concentrated loads. What is actually a concentrated load? So in concentrated load, what happens? It is a point load or concentrated load. Okay. So what is actually a point load? Now in point
Sharing a
load,
slide, sir.
I'm sharing a slide.
No, sir. We can't see anything.
No, I'm not sharing anything. Wait, I'll share it. I will share it.
Okay.
Just a minute. Try to understand. Don't. Then only I can say you, na. So what is actually a point load or concentrated load? So a point load means what? The load is basically acting at a particular point. Okay. That means what? That means if you see those, if you recall those, what do you call it? Diagrams before just now I showed you. I'll show you in detail. Just a minute, then you can understand. So in those kinds of loads, what happens? There are two supports. Now, if you see the supports, there are two supports at the edges for a simply supported beam. Now, if there are two supports for at the edge of the beam, then what happens? There will be certain amount of loads, right? Now, these loads will be acting in this manner. These loads will be acting in the beam. Look. So, did you understood the types of beams? Is it clear? The types of beams? Hello, hello. Is it clear for the types of beams?
Yes, for me, sir.
Now you go to
Yes, for me.
types of load. Just now I was saying that. Just now I was saying that the types of loads that are acting, right? First of all, this is a simply supported beam. Just now we showed you. Now I'll be showing the types of load in a simply supported beam only. So what happens is that if a point load act here, then this is a concentrated or point load. So suppose this is point A, huh? this is point B, the distance between them is L. Then eventually what will happen if a load of W act here, so this is known as what? Concentrated or point load. Okay, that means what? When the external load that is acting on a beam is concentrated at a single point on the beam. Now you can get, I think so. This is known as a point load. Now we come to what? Uniformly distributed load or UDL. So for UDL, how does it look actually? Look. Now in UDL, it looks like this. So this is what an UDL is. Okay. So this is a UDL. UDL means what? Look, the load is what? Uniformly distributed. That means what? In uniformly distributed load, suppose this is the distance L, it will be what? W kilonewton. Now, since it is uniformly distributed, so it will be what? W kilonewton per meter. Okay, this is known as the uniformly distributed load. That means what? When the external load acting on the beam is distributed over a length of beam, the following load is said to be what? UDL. Now look, what is an example of UDL? Suppose there is an water tank above a beam. So the load that is acting, it is uniformly acting on the beam, right? So that is known as uniformly distributed load. Okay. So the load of UDL is acting per meter length. Okay. So now I'll show you certain pictures, then you will understand it more clearly. Now if you can see, can you see the this one? Can you see it? Okay, so if you can see here, what are the different types of loads? Look, here there is one concentrated or point load. So that means what? This is shown in a different member, but it can be acting in this member. Okay, so these are concentrated or point loads. Now uniformly distributed load. Just just now I showed you this is uniformly distributed load. Hmm. Now uniformly varying load means what? It is varying. Okay. So this one leave it for now. Leave it for now. We will discuss it later. So this is uniformly varying load means what? Look, this load here, a load of W is acting per meter. That means what? This is uniformly distributed load. Now, if it is acting per meter, then if we measure, suppose this is L meter. So if we measure the whole distance W into L, then we will get what? In the form of a point load, right? we'll get all this thing. It is acting whole now per meter. Suppose this is 5 kilonewton per meter, and the distance between L is equal to what? 4 meter. Now, so in order to convert this thing into a point load, we can just multiply it with the distance, then we will get the point load. Okay, so this is how it is being done. It'll be clear for you once we do the numericals. Okay, now another important thing that I want to tell you is regarding this one. What are actually the different type of supports? So if you can see the slide I'm showing you, if you can see the slide here, look, these two are the different type of supports in a simply supported beam. Okay, this should be clear to you actually. This is a hinge support. We'll discuss these things in maybe next semester. You'll be getting for some structural analysis, but then you can discuss it in more elaborate manner. So as of now, you just remember it. This is a hinge support. If the support is in this manner, and this is a roller support. Look, there is a roller sort of thing, right? So this is a beam. So these are the two different supports. Okay, different supports. These are the different supports in a beam. So these are the different supports in a beam. Okay, so these are the two supports. So remember these things. These are very important for me. So different types of supports. Now let us go. So here only, look, just now we discussed it now. So is it clear for you what I have taught? Yeah, students, is it clear for you? Is it clear for all
Yes,
of
sir.
you? Okay, fine. Good. What about others? Same method is responding. Anyone else is facing any doubts? I guess.
Sir,
Ah, John Kelly, right? Hello. 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 Yeah, yeah. Ask your doubt. What you're facing? Your mic is coming, please. Any doubt, John Kerry? Yeah, say. I'm not able to hear you. Look, you write in the chat box. So, types of loading here it comes. Number one is concentrated or point load. So when external load is acting on the beam, concentrated at a single point on the beam, then it is called concentrated or point load. That one I explained. Now uniformly distributed load UDL. Now what is UDL? Just now we discussed, right? When the external load acting on a beam is distributed over the length of the beam. That means at the whole length of the beam, there is what? The load is distributed. So the following load is said to be what? UDL. For example, self weight of the beam, then water pressure at the bottom of water tank. So it is measured by what? Magnitude of load per unit length. That's now we discuss now W per meter. So for solving problems, what happens? The total UDL is converted into point load. That means what? You simply multiply with the length. That means this length of the beam or the distance between the two supports with the load, and then eventually you will be getting the in the form of point load. Now in uniformly varying load, the last figure that you saw, the last figure that you saw, what happens is now, what happens is now that the load spread over a beam is uniformly varying. That means what? It is not neither it is neither uniformly loaded, neither simply supported. So that means what? The load at some point is what? It is less, and at other point it is what? Increasing. Just now we saw the diagram. So that is known as what? Uniformly varying load. Okay. So this is known as the uniformly varying load.
Hello, sir.
Yeah, bro.
Uh, what if we put in point load? What if we put point load in one side of the support?
One side of
Only
the
one
support
side
or
also.
beam.
That doesn't matter.
One side of support or beam.
Yes, sir.
One side of support or beam.
Support, sir.
I'm not able to get you. What you are saying? One side of
मतलब सर अगर अगर
हाँ
हम लोग एक पॉइंट को पॉइंट लॉट में ना
एक
वो
पॉइंट
जो
लोड को
एक पॉइंट को हाँ एक पॉइंट लॉट को मतलब एक पॉइंट लॉट लॉट उस सपोर्ट में अगर रखता है सिंपली सपोर्टेड बीम में तो कोई
हाँ
फर्क तो नहीं पड़ता है मतलब एक
उसका
साइड में रखता है बोलने से
अच्छा मैं दिखाता हूँ ऐसा है क्या रुको मैं ड्रॉ करके दिखाता हूँ यू वांटेड टू नो दिस ना पहले मैंने मिडिल पे दिया था अभी अगर इस जगह पे होगा लोड तुम इसके बारे में बोल रहा है ना है कि नहीं तेमजाद हेलो
yes sir, I'm talking
हाँ
about that.
so this one will be just as simple as that like initially it was in middle so the analysis would be really different look for analyzing it or for calculating mainly what you need to find out is after putting the loads you have to find out the shear force and bending moment. The next topic is only shear force and bending moment. We'll just discuss the definitions. So what happens, just what is important is suppose this is W na, this W load is acting here, so we can measure a distance here. Suppose this is, if the total is suppose 5 meter, huh? If the total distance between A and B is what, 5 meter, then this distance can be 4 meter, है कि नहीं? और ये distance क्या होगा? What will be this distance? This will be 1. So this is the difference. You just put it in this side, then the calculations will be different, and the values of A and B will be different. The values will be different, but load can be put anywhere. That is how a building is done, na? Suppose in a cantilever beam. In a cantilever beam, it is something like this. In a cantilever beam, it is something like this. So what happens? I just put the load here, no? So you can put a load, another load here also, or here also you can put another load in simply supported. Then the thing will be different. Or maybe between these two, there will maybe some uniformly distributed load also. It is not like it is not necessarily important that only one load will be acting on the beam. There may be numerous amount of load. Na? I'm giving a practical example. Think over it. Huh? Suppose there is a beam. Huh? Yes, that day I told you regarding what is a beam and all. Na? Suppose there is a beam. So what happens? In that beam, hmm, if in that beam what happens? There will be an uniformly distributed load. That means that load will be in the form of what? That the beam has some self weight, right? Huh? So what happens? That is an uniformly distributed load is acting on the beam. Now, apart from that, what are the other loads that might act? Suppose someone is standing over it. Huh? Suppose some person is standing over the beam. Then that load will act on the beam. Huh? So eventually that load will also act. Now, if you suppose place anything else on the beam, then that load will also act. Are you getting me what I'm saying? Hello, are you
Yes,
getting
sir.
me?
Got it.
Ah, good.
Yes, sir. Yes, sir.
What about others? Anyone? Any doubt? One will respond, I think so. Okay, fine. So this is how the beams are there,
Without.
right? Yeah, no doubt, no? Okay, fine. So in a cantilever beam also similarly what will happen? Suppose at the edge someone is there, huh? Like this. So then the load will be acting at the edge. Now someone is at the middle, huh? Then the load will be acting like this. Now two people are standing, suppose in the cantilever beam, or two loads are present. That means in this manner. Now if you put an uniformly distributed load UDL, so it will act like this. Suppose UDL is put, we can put an UDL. So the loads, n number of loads can be put unless it fails, huh? But eventually it will what? That analysis part, how is actually it is being analyzed, that will be a bit different. That's it, nothing else. So now look, there are two terms now: shear force and bending moment. Huh? Shear force and bending moment. What is shear force? Just now, suppose it is given in the definition. If you see, when the beam is loaded in some arbitrary manner, some internal forces and moments are developed in the. So if this beam, suppose this is the beam, suppose so this is the beam, right? So this beam is what loaded. Huh? This is the load. This is the load. Then this is the load. Then that means what? Some internal forces or moments are developed, and the term shear force is known as what? Algebraic sum of all the vertical forces. That means what? This force is acting, this force is acting, this UDL is acting. So if you add all these forces which are acting left or right to the section, just remember this part. So suppose this is the beam. Now if you divide it into two sections, you have to find out what? Either left, right of it, this side, or either left of it. So these two sides, either acting in the right or left of the sections, is known as what? Shear force. Now shear force is fine. You have found out the sum of the forces. Huh? After that, what happens? You'll have to find out what? After that, what happens? You'll have to find out. Now, after force is acting, there will be certain moments. Moment you all know, force into perpendicular distance. So if there is some moments, then what will happen? Huh? So if there is certain amount of moments, then the force into perpendicular distance, or then the term bending moment will come. Bending moment means what? It is the algebraic sum of the moments of all the forces. Now look, suppose here, if we think of this part only, only this part. Look, this is the section. Now here it is B is present. Now here B is present. Here we have what? One point load concentrated, and here we have one UDL. So this is the section that we cut. Now what? How to find out the moments now? Now you have to find out the distance from this section of this load. So how force into perpendicular distance, that thing only comes into play. So summation of all this, like this force into this distance, then this UDL into the center distance. So UDL is measured from always from the center. So that center distance. So these things if you add up, then it comes out to be the what? Bending moment. So the algebraic sum of moments of all the forces that are acting to the right or left of the section is known as what? Bending moment. Okay. So this is how we define shear force and bending moment. Do you have any doubts? Do you have any doubts?
Yes, sir. Once again,
Bolo.
shear force, sir.
Okay, shear force. Look, the algebraic sum of all the forces that are acting to the right or left of a section is known as shear force. So suppose this is the beam. So there is one. We cut the beam into half. Suppose there is one force acting here, and this is what? If this is the support, this will also give one reaction force, right? So these are the two forces that are acting. So if you add these two forces, then that means what? For this section to the right, these are acting. So if you have to add these two sections, then the algebraic sum of these two forces acting towards this section to the right of this section will be shear force. That means basically shear force is what? The summation of all the forces that is acting on the beam. Just as of now, simply remember that thing. And the bending moment is what? Summation of all the moments, huh, acting to the right or left of a section is known as bending moment. That means what? Suppose there is force into perpendicular distance is moment, no? So that moment, suppose this is the perpendicular distance. So this force is acting at this distance. Okay. So that means what? If this distance are present, then the force into perpendicular distance is known as the bending moment. Okay. So that is known as actually bending moment and shear force. You can understand little bit now. Temazar. Temazar.
Yes, sir. Yes, sir.
Okay. You asked me for any doubt. Just try to recall these things. The next class, if you have any doubt, you can ask me. Okay. I think it's fine for every one of you. Sorry. Anyone else? Any problem? I think so. No one has got any problems.